Hello, everyone. I'm Ted Ingalls, and I'm the founder of Athena Ultraviolet. And speaking of mighty purposes, I started this company because I couldn't think of a better one than the preservation of public health for the next 20 to 30 years in the single most important area, which is the growing issue of antibiotic-resistant bacteria. So by 2050, by the best estimates, antibiotic-resistant bacteria will be responsible for more deaths than cancer is today. And indeed, in the United States, we're well on our way towards that path, regrettably. Last year in the United States, 100,000 people died from what are called healthcare-acquired infections, or infections that patients received after they checked into a hospital, usually for surgery, perhaps for cancer treatment. And these are conditions like pneumonia or sepsis, horrible illnesses that target patients that are already the worst off, the very old, the very young, and those with weak immune systems, especially those receiving cancer treatment or something like HIV/AIDS treatment. And I mean, just picture it. You've been diagnosed with breast cancer. You make a brave decision to be treated with chemotherapy, and after months fighting in the hospital, weak and in bed, you succumb to a deadly strain of drug-resistant pneumonia. It's a horrible fate, and we should be doing more to protect those patients. What you're looking at right here is a picture of the University Research Hospital in Montpellier, France, and it has a very important story. This hospital, by all external measurements, is a wealthy, fastidious, and cutting-edge hospital. Why then was it the site of an outbreak of deadly Klebsiella oxytosa that lasted for more than 2 years between 2012 and 2014? An epidemiological team in 2015 set out to find answers. And they investigated cultures that were taken from all areas of the hospital. They swabbed every surface they could think of. And their conclusion was that the problem was in the sinks. The hand-washing sinks that have been the biggest move forward in personal hand hygiene in healthcare are turning out to have a dark side. Up here on the screen is the largest and most recent meta-analysis of the epidemiology of what are called carbapenem-resistant bacteria. These are bacteria that the director of the CDC has referred to as nightmare bacteria. They are resistant to all forms of treatment with antibiotics, and sinks are the #1 most cited environmental reservoir of these bacteria. We need a solution. The scientific evidence is overwhelming. In one paper that I read, more than 30% of sinks in the ICU were contaminated with deadly strains of Klebsiella, and even more sinks were contaminated with another deadly bacteria called Pseudomonas aeruginosa. Now, if 30% of sinks had bombs in them, this would be a serious problem. And I mean, if 30% of sinks leaked, this would be a serious problem. But 30% of sinks have the potential to kill the patients that stay in the rooms that they're in. There was a study done in response to that study, where doctors and infection control professionals simply removed hand washing stations from sinks. And the outcome? An almost 4-fold decrease in the incidence of Klebsiella and Pseudomonas infection in that hospital. Treating the sinks works, but the problem is, if you rip out the sink, now you don't have a sink. So what can we do about that? So I've described the problem from my perspective, from the scientist's perspective. How does this look from the inside of a hospital? First, bacteria are more deadly and contagious than they ever have been. They've acquired resistance to a vast array of antibiotics. Infections last longer, and they're more expensive to treat. And increasingly, Medicare and Medicaid refuse to pay for treatment, which means that hospitals end up footing enormously expensive bills every time patients get sick. And lastly, when hospitals fail to meet safety standards, they're punished by Medicare and Medicaid, and their reputation goes downhill. It's a huge problem. Regulations have never been higher, and spending on infection control is increasing rapidly. This is a $45 billion problem by the lights of the CDC, adjusted for yearly, doesn't matter. Hospitals, or at least your average long-term acute care facility, can pose up to $20.6 million per year of direct spending associated with paying for these infections. And the average infection costs north of $30,000 to treat. I mean, that's a shocking amount of money. So this is the exciting part. This is where we get to talk about our solution. So judges, if you could simply pass down the part that I've printed. What you're looking at right here is what's called a Tesla valve. This was designed eponymously by Nikola Tesla in the 1920s. It is a one-way valve with no moving parts, and what it allows us to do is ensure that the water that goes into sinks stays in sinks. The reason why bacteria like Pseudomonas and Klebsiella grow out of control in these sinks is because there's a permanent pool of standing water at the bottom of them, which is warm, isolated, and moist. If we can ensure that that water only goes in one direction and never comes back to the patient, then we have an extremely simple and elegant solution to a deadly problem. So this is what I propose. Up here, you see a sketch that I've done in detail. On the one side, going down, is exactly this valve. On the other side is a swing valve that leads out directly to the wastewater system. It doesn't look like much, but this is 3 days and $300 away from coming out of a CNC shop in Chicago and into my hands. This prototype is ready to go. Now, this will also be made out of 100% copper. Every single part in this device will be made out of copper, which has remarkable antimicrobial properties, able to kill most organisms living on its surface in less than 2 hours. This installs under any ordinary sink using standard fittings, and compared to sink steaming and chemical disinfectants like alcohol, chlorine, and quaternary ammonium, it's a great solution. It's inexpensive, and most importantly, it's automatic. It doesn't require anyone to use it. It simply cleans itself. It's cheaper than sink replacement, and it's easier to use than sink steaming. So talking about where we're going to start and what the market looks like. There are 5,500 hospitals in the United States. Of those, long-term care facilities, because they house patients for long periods of time, usually that are immunocompromised, have much higher rates of infection, and so they're a natural candidate for our service. There are 7 of those facilities in Chicago, which is where I'm from, such as Kindred's, Billings, and Hastings. So what does it look like to go from here to there? Step 1, we need to raise money to prototype and test this product and make sure that it really works the way that we think it works. Then, we need to ensure that this product can go into a real-world situation and come out with compelling evidence of its efficacy. So we're going to partner with a regional hospital in Chicago, potentially OSF, in order to do a 6-month pilot trial in real-world conditions to assess pre- and post-intervention clinical data. And then in the last phase, if that works, which I truly believe it will, then we enter the growth stage. And at this point, we're able to really build out our product base and sell. So to put this in terms of economics for the decision maker at the hospital, if this device can prevent only 2% of infections, and remember, removing sinks cut infections down by cut them down to 25%, then the hospital is keeping an additional almost $500,000 in direct costs alone, not counting indirect costs like cohorting and so on. So that's a almost 7 times return on investment, a great standard for medical devices in the industry. So here's our value proposition, our unit economics sort of written out. So yeah, I'll move on. Up here we have our financial projections. I won't dwell too long on this. What's important is that in quarter 6, we become cash flow positive, and in quarter 8, we earn a positive net balance. So I want to talk for a second about the team. Obviously, I'm part of it, but I'm working with 3 absolutely brilliant people to realize this vision. The first is Moose Chagall. Moose is someone that I met through the College New Venture Challenge in Chicago. He's a brilliant entrepreneur, and he designed and manufactured the best-selling sink at Lowe's for more than 2 years. He's an expert in the manufacturing and distribution of plumbing parts, and that's why he's on the team. He also is on a first-name basis with the family that runs Medline, which we're excited to consider a partnership with. Zoe Kwan is my technical and scientific advisor. She's a biochemist and a biophysicist, and she runs a startup consulting firm that specializes in medical devices. Carol Sahulius is a registered nurse at Sharp Memorial Hospital, and she's working with me to help build something that will fit in seamlessly and effortlessly into the work stream of healthcare professionals. And then there's myself. I don't know as much as these people, but what I want to emphasize is that I'm extremely committed to this project. I made an executive decision to graduate in 3 years rather than 4 from my college, and in 8 weeks, I will be working full-time on this startup. I'm diving headfirst into this, and I am hoping for a splash rather than a thunk. So, I want to build out a team. Right now, I'm a solo founder. These are my advisors, my board members, but I want people to join me. If you have expertise in healthcare, in device manufacturing, or in legal issues for healthcare startups, then I want you to start a conversation with me. I've put my email up here for anyone that's interested. Nothing formal, just a short note. Right now, as I mentioned, I'm seeking $100,000 to prototype and test this product and ensure that it really works before going to a larger market. Lastly, before my time ends, I just want to ask, what could be possible if this works? If this works just as well as the clinical intervention with removing sinks, can a $50 device save lives automatically? Can we prove once and for all that sinks are the source of so many problems in healthcare? And can we do something about the rise of superbacteria, one of the greatest existential threats to humanity? Can we protect the people that most need our protection? Children, cancer patients, and those with HIV/AIDS. This is my question. This is my research project. This is about a value-centered business. What better value than the preservation of human life? Thank you.
I'm going to just chime in because I'm not a medical person, and I'm going to leave it to the other people. I just want to say that I'm so impressed by you. I read the business plan yesterday. I wrote on my notes, all of my notes, just basically I just said love it. So my only comment would be, or question also would be, does this kind of bacteria build up in homes as well? And is this something that could also go into the residential market?
Got a news flash for everyone. 35% of sinks have salmonella. You're welcome. So yes, it absolutely does build up in homes. This has been proposed as a consumer product. If I can just say something slightly geeky, the reason why you cannot get rid of these bacteria is what are called biofilms. Think of this as like saran wrap for bacteria, sort of like plaque on your teeth. And so when bacteria live somewhere for a long time, they form these really thin, sticky layers that are very hard to get rid of. And so this is probably true in your kitchen sink. It's probably true in almost any sink in the world. So yeah, it is a huge problem.
Great job.
Thanks.
So I really think this is an interesting idea, and there's a lot of data that does support that sinks are a problem, and splashing back to you in the sink is a problem. There are some other small startups that are making UV lights that are sitting underneath the medicine cabinet or close to the sink with a radius that is supposed to sort of kill the bugs that are splashing back up.
In the basin.
In the basin, correct.
Basin's not the problem.
Right. So, well, it is if it splashes back up, it's a problem. But it's not the source of the problem, right?
Right.
So my question to you is, if I read the business plan right, it looks like you've pivoted on the product.
Absolutely.
Okay, so maybe you could fill us in on that, because it seems like you've simplified the product. Before it had a copper, it had antimicrobial plastic, and it had these LED
Of course.
lights. So.
Well, I hate to rain on someone else's parade, but what I realized is that UV light couldn't be powerful enough to reach down into the 1 foot long segment of down tube in that drain and penetrate water and penetrate whatever gunk is living down there. And so I wanted something that worked independently of power, and I realized that there was a way to do it easier and more simply. And one of the great sort of medical mysteries is, you know, these bacteria, like Pseudomonas is a great example, can really only survive on a wet surface.
Mm-hmm.
How many wet surfaces are there in hospitals? And so the basin gets wet, but it dries out, unlike the sink drain. And so in a lot of these studies that I've looked at, especially one in the University Hospital in Nantes, France does a lot of these studies, I don't know why, they swabbed the basins of every sink in the hospital and they found almost nothing, whereas in the drains they found an unbelievable amount of bacterial activity. And it makes sense.
Have you seen a company called Sharklet?
Nope.
Definitely want to check it out. I think some of the research came out of the University of Wisconsin, but don't quote me on that. But what they found out is that sharks, for some reason sharks, they don't have any bacteria that sticks to them. And what they found
I don't know
out,
what a shard is.
a shark, like
Oh, a
Jaws.
shark.
Yeah, shark.
Okay.
A
Thank
shark
you.
is something totally different, but we won't talk about it.
Yeah,
So, shark, I had to say that. That was a gift. It was right there.
microphones.
No,
Cash
it's
cab
good.
guy.
So, wow, it's hard to come back from that one. Anyway, sharks, the skin of the shark, if you looked at it at a microscopic level, which, you know, who doesn't? If you do, it's comprised of tiny geometric shapes, and because of the actual shape and the size and scale of it, bacteria can't physically stick to it. It's really
Right.
interesting. So there have been a lot of tests in hospitals on things like the handles that go alongside the beds, the railings, because they get touched by everybody. And when they make the surface with the Sharklet technology that imitates the structure of a fine microscopic shark skin, no bacteria sticks to it. just something to check out. I think what you're doing and the mission is really, really awesome. I'll tell you another fun study you might really get a kick out of, and it could lead to more business ideas. I believe it was a Florida high school student did a test for she ran this as part of a term paper, and she took water samples from a certain fast food chain's toilets and compared the water to the water that was in the hoses going to the ice makers in those restaurants.
Yeah.
And believe it or not, the ice makers were filled with far more nasty stuff than the toilets in the restaurant.
Bacteria don't die when you freeze them.
So there's a lot of stuff going on, a lot of applications for this. And I think obviously helping people who aren't there to help themselves with something that is microscopic and undetectable by most and not even realizing the damage it's doing is certainly a very valuable thing. And obviously helping people is great. And it does seem like if air pollution is worse in your home than it is out of doors, right? It's another fun data point. Imagine what you could do with some of the technologies you're leaning towards and what they could do in the home as well as in the hospital. So I think it's a really big idea. It's one of those things that's hiding in plain sight, even though the sink is inches down the pipes. But anyway, just congratulations. I think it's a really cool idea, and I love that you're accelerating your personal exit plan from university to go for it all the way. So big ups.
Yeah, your passion on this project is, we can see it, and we can feel it. It's very goosebumpy. It's kind of cool. One of my best friends is a vegetable in a hospital in London right now.
I'm so sorry.
Because of infections. And she was
Wow.
supposed to go in September, and she's never come out. So it's a personal interest of mine. But I see him holding his card out. Come get my card, because I also want to introduce you to a potential advisor.
Of course, I'd love to. I'm
Yeah.
so sorry about your friend.
Well, thank you for doing what you're doing.
It's awesome.
I thought your passion is really exciting to me. Patient safety and the elimination of preventable harm is something that I'm very passionate about and been involved with my whole life. Most people don't understand that most of the dangers that occur in a hospital have nothing to do with why you're in the hospital. They're, as you've already addressed, they're in places that are easily seen but not seen. And I'm just curious, though, with your prototype change, with your trial coming up in Chicago at the hospital, walk us through with your Tesla model, how will this be inserted and how often does it need to be changed out? Or
Right, so my mentor, maybe I can go back to my diagram. My mentor, Moose Chagall, because he's an expert on sinks, I don't know where you find these people, but he is. His proposition is build the whole drain assembly.
Oh, I see.
Right? So if you've ever assembled a sink where you plug in the bottom part and then you connect it out to the U-pipe and the rest of the wastewater, it works exactly the same as any drain assembly that you would buy at Home Depot. And so anybody that's ever done the very mundane task of putting together a sink, especially if you're facilities manager, facilities personnel at a hospital, they'll be ready to do this out of the box. Mm-hmm. It sort of screws in standardized NPT threads, and then it just connects directly to the S-pipe. So.
How do you see in part of your study doing your testing?
It's just a matter of looking at, hopefully we want to operate on the longest possible time scale, but we also want to bring the product to market soon. So we're hoping that we'll get actionable, statistically significant data from the 6 months post-intervention. So we're hoping to replace with OSF every sink drain in their ICU. Okay. And then look at their patient safety outcomes in the ICU before and after the intervention. And if the data is still fuzzy because there's some seasonality in how people get infections in the hospital, then we'll extend the study out longer until we can see clearly what's working and what isn't. And then that data will become part of the way that we market our product.
Are you familiar with the Institute of Healthcare Improvement in Boston, in Cambridge?
No, I haven't.
Okay, well, I can help you with that. And also, our university started the only Institute of Patient Safety in Texas because, and we'd love to talk to you, but in Texas alone in DFW Metroplex, 10,000 people die every year from patient safety, preventable harm issues.
Wow,
So you've addressed a key one. A lot of people don't understand also that it's 30% of the total healthcare budget is money spent on preventable harm. So I really applaud what you're doing. It's not the beautiful, sexy, fun things.
It's just
but
a
it's
pipe,
the things
right?
that saves it's just a pipe thing, but it saves lives. So congratulations. Congratulations.
Thank you.
Ted, thank you very much. Join me in thanking the University of Chicago.